So this is a given finite automata and these are the strings. So you need to check whether these strings are accepted by machine or not. So let us take the first input string 001. And here you can see delta of Q0 on 0, it is moving to Q0 as well as Q1. So we are taking both the states and we need to check both the states in parallel. So Q0 on input symbol, first input symbol 0. If it moves to Q0, then the possibility is now still you are in Q0 only and you need to check the second input symbol. So Q0 on second 0, again it moves to 0 as well as again it moves to Q0 and Q1 only. So again we need to take two possibilities. Say for example if Q0 on 0 is moving to Q1 and now we need to check the second input symbol, then Q1 on 0 there is no path, so we'll get 5. So there is nothing in this case. So we can't follow this up this way. You need to check in this way only. Now again Q0, Q1, two possibilities like before. So we completed first two characters. Now check the third one. Q0 on input symbol 1. Again, it stays in same state. Whereas if you take this Q0 on input symbol 0, if it moves to Q1, then the possibility is check the third input character. So delta of Q1 on 1, it moves to Q2. So here you can see the machine reaches the final state. Q2 is final state. So it should go to final state either in the first path or in the second path. Then we can say that string is accepted. Now take the second one 0, 1, 1, 1, 0, 1. So for this also, again Q0 on first input symbol 0. It is moving to Q0 as well as Q1. So take two paths. If you move in the first path, then if the machine reads the second input symbol Q0 on 1, it stays in the same state Q0 and read the third character Q0 on 1 again stays in the same state. Next one Q0 on 1 stays in the same state. Then Q0 on 0 again we have two possibilities Q0 and Q1. Say for example, if you take this Q1 as the next state for this delta of Q0 on 0 and now check this path. So delta of Q1 on second input symbol 1, it moves to Q2. Then read the third character 1. So now we are at state Q2. So Q2 on input symbol 1. So there is no path. So it is 5. So you can't or the machine can't traverse in this direction. So move to the previous one. Now you can see already machine completed all these already machine read all these characters. Now it is at last character 1. So if it reads in this way, then Q0 on input symbol 1 is Q0 only. It is not a final state. So you need to check this Q1 direction also. Q0 on input symbol 0. If it is Q1, then read the last character. So Q1 on input symbol 1, it moves to Q2. So Q2 is the final state. So as the machine reaches the final state, here we can say that the string is accepted. Now moving to the third one. First Q0 on input symbol 0, again Q0, Q1. If the machine goes in the Q0 path, read the second character 1, it stays in the same state. Third character 1 stays in same state. Fourth character 1 again stays in same state. Fifth character 1 stays in same state. So here you can see both of them are same. There is no 1 at the end. So that's the only difference. So you can see this complete part till here is same. In the same way, this part also, this is same. There is no 1 at the end. So that's the only difference. So you can see after reading the 0, this machine, it is staying in Q0, Q1. but both of them are not final states. Q2 is a final state. So here we can say that the string is rejected by the automata. And the fourth one is 0, 1, 0. So Q naught on input symbol 0, Q naught Q1. If machine goes with this path, read the second input symbol 1. So Q naught on 1 is Q naught only. Then read the third input symbol 0. Again it stays in. It moves either to Q naught or Q1. Whereas if you take this Q1 path, then on input symbol 1, it is going to Q2. On input symbol 0, there is no path. So in both the cases, machine is not traversing in the right direction, or it is not reaching the final state. So we can say that the string is not accepted or it is rejected by the automata. Convert the given DFA into regular expression using Garden's theorem. So first take Q1. So there is no path or there is no incoming edge to Q1. So it is just epsilon. As is initial state, we need to add epsilon to initial state. Then Q2. So Q2 is having incoming edge from Q1. So it should be written as Q1 dot A plus Q1 dot B. At the same time, it is getting input or incoming edge from Q3 as well as from Q4 on both the input symbols A and B. So we wrote it as Q3 dot A plus Q3 dot B, Q4 dot A plus Q4 dot B. Then find out Q3. Q3 is having incoming arrow from Q2 on input symbol A. So this is Q2 dot A. Q4 is having incoming arrow on input symbol B from Q2. So this is Q2 dot B. And in this diagram, Q3 is a final state. So we need to solve that. Q3 is nothing but Q2 dot A. So we need Q2 for solving Q3. So let us solve Q2 first. So Q2 is write this complete equation. Then in place of Q1, we need to replace epsilon. So epsilon dot A plus epsilon dot B. And in place of Q3, we need to write Q2 dot A. So in place of Q3, write Q2 dot A dot A. Then here also Q2 dot A dot B. In place of Q4, write Q2 dot B. So in place of Q4, Q2 dot B and write this A as it is. Then here also Q2 dot B, write the B as it is. So here you can see Q2 is common in all the terms. So take it common and write down AA plus AB plus BA plus BB. And we have two terms A and B. So that is A plus B. This is in the form of R equal to RP plus Q. So you can write it as QP star according to Arden's theorem. So Q is A plus B, Q, P value is this complete term. So that is P star. So now we got Q2. So you can solve Q3 by substituting Q2 in the equation. So Q3 equal to Q2 dot A. So place this complete Q2 term here in place of Q2 and multiply that with A. So this is your final result.